Okay, Unit 6, moving along. In 2022, there were roughly 350 eastern box turtles found in Michigan. Population is increasing by 12% per year thanks to zoo breeding programs. Write an equation that represents the number of turtles in Michigan in X years. Then find the number of turtles that should be expected in the year 2030. So, it's really a two-part problem. It says write an equation that represents the number of turtles, then actually find the value in 2030. So this is a two-parter. So this is all built off your basic exponential function here, but with some spice. So if you remember, there's different versions of this, but I think the one we use, population after time is equal to the initial amount times 1 plus rate to the t power. Now that doesn't need to be plus. If the population's going down, you just fix it. You make it a minus. So let's fill some things in here. So what we're going to get, remember this is y, so you could replace that with y. It's the same thing. So, or keep it, equals, the initial amount is 350. It's increasing by 12%, so it's going to be a 1 plus, we got to convert that to a decimal, 0.12 to the t power. And so we're going to clean this up a little bit. We get y equals 350, 1.12 to the t power. Now if somebody kept it more in this, and they wrote 350, 1.12 to the x power, that'd be fine too. You just have to know what these pieces are. This is time. So there you go. But then it says, number of turtles should be expected in the year 2030. Well, you can see here that there's been 8 years between here and here, so we're just going to plug that in. I'm going to choose this one, 350, 1.12 to the 8th power. So give me a second, I'll be right back. Alright, got my calculator, so 1.12, raise that to the 8th power. PEMDAS, got to do exponents first, then multiply, and we'd get 866.58, approximately 866. Whoopsie. 866. And in my class, if you said 867, that'd be fine too, because it says that represents the number, and then find the number of turtles that should be expected. So you could round up or round down. I mean, it's just kind of a rough estimate. You never know about that one little turtle. Is he going to make it? I don't know. You can make a movie about it. Here we go, number 13. Find the inverse of the function. Well, remember, this is y equals log of 8x. All right. So the first thing you have to remember is that the inverse means switch your x's and your y's. And also don't forget there's a 10 down here. If there's no base, then it's assumed to be a 10. So the first thing we're going to do is actually switch the x's and the y's. So this will be x equals log 10 8y. And now we're just simply going to follow the rules of logarithms. Start with a base, go to the exponent, go to the answer. So that would turn into 10 to the x equals 8y. But remember, you're not done until you solve for y. So you divide by 8, divide by 8. So we get 10 to the x over 8 equals y. Now technically, you're not supposed to stop here. The inverse is like this. So you're really supposed to replace that with that symbolism, because y equals this, y doesn't equal that. It's already been claimed that y equals this. So the inverse should be denoted, as they say, in that language. So that's your real answer, and that's good. So 14. Yes, you could slap logs here and slap logs on here. You don't have to do what I'm about to do, but I look at this 5 and I look at this 125 and I know that I can common bases happy places. So you go for the bigger one and you try to match the smaller one, which I'm going to do right away. So that's 5 cubed to the x minus 6 power. But then I'm going to recognize this is a power to a power. And this just kind of comes along for the ride. And now that I got common bases, they just disappear because this stuff has to equal that stuff. And we get to solving. So subtract 3x, minus 2. We get 2x equals negative 20. Divide by 2, divide by 2. We get x is negative 10. And that's how you do it. And yes, you can slap a log on here and slap a log on here. Bring that in the front, bring that in the front. But I'm not going to take up your time doing that on this problem. That was not the intention of number 14, I don't believe. Okay, number 15, it says find the average rate of change. Remember, in this class, with this new Algebra 2 jargon, that's just the same thing as slope, which is this formula right here. So really we need, what that's saying is we need 2 points in order to use this formula. So all of that leads me to really what I need to do. Then it says here's your equation, which is the same thing as y equals 1/2 times 2 to the x power in the interval 0, 4. So really it's saying let x be 0 and let x be 4, and we're going to create our 2 points right here. Do you need to know what this looks like exactly? Not really, but it's nice to see it. But in this problem, let's get to work. If we put 0 in for here, 2 to the 0 power is not 0, it's 1. 1 times 1/2 is 1/2, or 0.5. And then if we put a 4 in there, it gets a little interesting. 2 to the 4th times 1/2. Well, 2 to the 4th is just 2 times 2 times 2 times 2. 4 times 4 is 16. 16 times 1/2 is 8. So here's our 2 points. 0, 1/2. And we'll call that x1, y1, just because I looked at it first. And then 4, 8. That's x2, y2. And we're just going to plug it in, see what happens. So y2 is 8 minus y1 is 1/2. That should be interesting. And then we get x2, which is 4, minus x1, which is 0. So really, what's 8 minus 1/2? That's 7.5 divided by 4. So you take your handy dandy calculator, 7.5 divided by 4, and it is 1.875. There's the rate of change. Now if you really wanted to look at it, they're asking you to find this point. Whoops, there's 0. Let's say that's 1. 0, 1/2 is this point. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So you go like this. So 4, 8. So they're asking you to find that slope right there. That's what the problem's asking you to do, but you don't need to really have that picture. Okay, so what is the solution? In other words, find x to the equation diddle-a-duh. Remember, base, exponent, answer. So base, start there, exponent, right there, equals the information in our answer pocket. So don't go 3 times 3 is 9. This is 3 cubed, which is 27. All those little mistakes that we make. 27 minus 9 is 18, equals 3x, divided by 3, we get x is 6. Alright, cruising right along. Unit 6 review. Use the properties of logarithms. Notice we've got 1, 2, 3. Now this is what I call marriage, where the 2 become 1, but there's actually 3, so we're just going to use that rule twice. But we got to look for law 3 first. What am I talking about, law 3? If you've got something in front of a logarithm, in order to clean it up, you should put that here, put that there first. There's nothing to do here. I'm going to put that right here. Now, me personally, I'm just going to rearrange this a little bit. I'm going to do these first, and I can see it's log of this stuff plus this log. The Mawage rule, addition means multiplication, so I multiply this stuff together. I'm ignoring this for a bit, because I'm going to do that last. And so these two right here become one log. So I get log, then I multiply b to the 6th, d to the 4th. Now I still have this minus log c. Now remember, what is this rule? Subtraction. Well, subtraction means division. The 2 shall become 1. The 2 logs become 1, and then this stuff is divided. So this is b to the 6th, d to the 4th over c. And there it is. All right, solve the equation. Well, remember in the previous problem, I said you could slap logs on because you just can. This one, there's no way you're getting common bases, happy places. So we're going to slap a log on here, slap a log on here, and use rule 3 by bringing that in the front. So I get x times, and I'm going to go to my calculator and I'm going to actually find this. So log of 4.602. I think rounding tenths, hundredths, thousandths is plenty. And then log of 6.778. And you can see what I'm going to do. Divide by 0.602. 0.602. So I'm going to take my calculator and go divided by 0.602. 1.29. Ish. Okay, number 19, find all the solutions. That means there might be more than one. Take the clue and run with it. But I'm going to show you something. Remember, back in the day, oh, where was it? Oh, never mind. Can't find it. But I said, I'm just making this problem up, but x plus 2 equals the square root of 3x minus 1, whatever. I'm just making this up. Problems like this, where you square both sides, and then you get x is this or this, you got to plug these back in to make sure you don't have a square root of a negative when you're done. Same thing holds true here. You got to check and plug x in to make sure you don't have any negatives in this spot, because it's impossible to have that. Why? Well, maybe for the last time, let's go like this. 2 to some power is equal to that. Well, no way is this possible. You cannot have a negative here, so that's what I'm trying to say. So with that in mind, let's get to work. Well, law 3 is sitting right here, so I'm going to put it right here because that's going to clean it up just a little bit. And then I can tell this is kind of like 2 to the x equals 2 to the 12th. X would have to be 12. This stuff has to equal this stuff, and then the logs disappear. This is kind of like common basis because that's a 10, that's a 10. X squared equals 5x minus 6. I got myself a nice little trinomial. Subtract 5x, add 6. Subtract 5x, add 6. X squared minus 5x plus 6 is 0. Looks very factorable. X minus 3 minus 2. A lot of students would go 6 and or negative 6 and 1 because all they're thinking is addition. You got to think this and this adds up to this, but this and this would make a negative 6. So negative 6, 1 doesn't work. So x is 3 or 2. Double check. Put the 3 in. 3 times 5 is 15, minus 6 gives us a positive. 2 times 5 is 10, minus 6 gives us a positive. We have no negatives, so these are both winner, winner, chicken dinners. Alright, so what is the 8th term? A little bit of a pain. In a situation like this, I think we're going to resort to prison math, but geometric sequence means there's something you multiply this by that gives you that, and then it's consistent. It's pretty obviously you multiply by 2, so that's our key. So that's our first, second, third, fourth, times 2 would be 48, times 2 is 96, times 2 would be 192, times 2 would be 384. Now that's 1, 2, 3, 4, 5, 6, 7, 8. Eighth term. You just have to know what this means. It means there's a multiplier. Okay. Find the amount of money of an account if there was $5,000 invested at 4.5% compounded continuously. There's the key, because we're going to use the old APERT formula. And you can find that on your cheat card if you built one. Hopefully you did. So, what's the amount of money? That's what they're saying. Find A. That technically should be of T, because it's all based on the amount of time you leave it. $5,000 times E. Remember what E is. It's a number. 4.5%. Move the decimal 2 places, so that's 0.045 for 40 years. That's the time. So here we go. Grab your calculator, and we got our little E right there. If you don't find it, remember E is 2.71, but we got to do PEMDAS first. We got to figure out what this is first. So 40 times 0.045. So now I'm going to go second E to that power, 1.8, enter, times 5,000. So we have approximately $30,248, and we'll just call it 24 cents. And there we go.